So for part A, this is the net ionic equation for the reaction. NH3 plus H plus yields NH4 plus. For part B, use the axis provided below. Sketch the titration curve that results when 0.20 molarity HCl is added dropwise to the 40 milliliter volume 0.10 molarity NH3. So, for this problem, we start by using the ice box and finding X, which also equals POH, or OH minus, which you can then convert to POH, which you then convert that to the pH. And so once we do all these steps, you get pH equals 11.13. So you start here, and you also know due to part C and D, the halfway point is 9.26 because pH equals to pK, and the pKa and the Ka for this equation is 5.56 times 10 to the negative 10. Then you plug that into the negative log, and that's how you get 9.26. So we go back to our graph and plug 9.26 in. We also have our equilibrium point due to part D, and in order to find it, you set up the equation like you're going to get Ka, but you set it equal to x squared over 0.067, then you cross multiply, and you will get 1.8 times 10 to the negative 5 x squared equals 6.7 times 10 to the negative 11. You divide both sides by 1.8 times 10 to the negative 5th, and you get 3.72 times 10 to the negative 11. And then you find the square root of each side, and you get x equals 6.1 times 10 to the negative 6 for H3O plus. Then you plug this into the negative log, and that gives you the pH, which is 5.21. So we go back to our graph and plug that in the rest of the way. For part E, from the table below, select the most appropriate indicator for the titration. Justify your choice. So when we look at this chart, we can see that we are given the pKa for methyl, red, bromothiamyl, and phenolphthalein, and for each pKa, we have 5.5, 7.1, and 8.7. So I chose methyl red because the pH at the equivalence point is equal to the pKa, and 5.5 was the closest to our pKa, which was 5.21 at equivalence point. For part F, if equal volumes of 0.10 molarity NH3 and 0.10 molarity NH4Cl are mixed, is the resulting solution acidic, neutral, or basic? Explain. So, for this problem, we are given the Kb, which is 1.8 times 10 to the negative 5th. So, we use the Kw, which is 1 times 10 to the negative 14, and divide that by 1.8 times 10 to the negative 5th to get the Ka, which is 5 times 10 to the negative 10. And we know that the Kb in this case is larger than the Ka, which means that the solution is basic.